Okay, now we're going to talk about the one situation where difference of longitude specifically gets more complicated. And that's when we go over to the far Pacific, out when we're near the anti-meridian, the opposite of the prime meridian. So either 180 degrees east or 180 degrees west. In an XY grid, if we were just talking about pure math, the coordinate plane never wraps around back on itself. So this isn't anything you ever have to think about, but it obviously does on the Earth. So you have to then ask yourself, well, how far apart in terms of longitude am I here and here? Clearly, you're not actually that far apart, but if you look at the longitude values of these 2 points, let's say this one is 175 degrees west, and this is 175 degrees east. Remember, east is over here, west is over here, because we're visualizing the Pacific, the far ends of the longitude grid, where things look like they're flipped. Well, obviously, this isn't actually a big difference. But if we follow the rules that we set in the last episode, to get the difference of longitude, you would add these two together, and 175 plus 175, you would get 350 degrees. This is not 350 degrees. 350 degrees is this all the way back and around to the prime meridian, plus this all the way back and around to the prime meridian. That's not the number you need in most situations. I can't think of a situation where you would need that number. You need this one right here. So there are two ways that you could deal with this problem that both work, and there's nothing wrong with one or the other. It just depends on what you prefer. You could either subtract both of these numbers from 180. So 180 minus 175 gets you 5. You do that for this, therefore getting this distance here. And then 180 minus 175 equals 5 up here for this distance, and then add them together. Or you could add them both together, get 350, and then subtract that from 360 to get 10 degrees. Either way, you come out with the difference of longitude here being 10 degrees, but it's just two ways of going about doing it. The way I usually like this one more, but there's nothing wrong with this method. This one is just saying, well, if 180 is the distance from the prime meridian all the way around here, and we're here, you find that little distance there, then you do the same thing for this side, find that little distance, and then add those two little distances together. Whereas this method here, you're just getting that whole distance around the Earth, stopping at these points, and subtracting it from the full circumference. It's whatever works for you. Let's take another example. Let's do one that crosses the equator as well, just so we can practice the latitude part of things. And let's say this is 172 degrees west, and then in terms of latitude, let's say that's 10 degrees north, and this can be 10 degrees south and 177 degrees east. Okay. Well, first, real quick, let's take the difference of latitude here. So we're crossing the equator. So the difference of latitude will be, we add this to this, 10 and 10. We have a total difference of latitude is equal to 20 degrees. And then our DLO, our difference of longitude, will be this distance and this distance. Remember, these two numbers show you the distances all the way around back to the prime meridian. So you have to, in my case, I'll do the way I like, do 180 minus 177 and get 3 degrees over here. And then 180 minus 172, get 8 degrees over here. 3 degrees plus 8 degrees, you'll get a difference of longitude of 11 degrees. I haven't shown you yet, but these are the notations we use, d-lat or d-long. Alternatively, you might see a cursive L for d-lat and a Greek lambda for d long. Just be prepared to write them either way because you'll see a lot of questions that go back and forth between the two. They both just represent latitude or longitude.